Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video introduces basic concepts of probability. Let's get started. We started our journey in statistics with some basic definitions, and we'll do the same here with probability. First, we need to understand what an event is, because when we calculate probability, we're always calculating it for an event. An event is simply something that happens, a result or an outcome of a procedure. Here are some examples of procedures. One person being born is an example of a procedure. 3 people being born is another example. Now, there's a special type of event called a simple event. This is an outcome that cannot be broken down further into simpler components. So if we look at the procedures that we have here on the screen, an example of an event for a single birth would be one girl. That's a simple event because you can't break down one birth any further. Likewise, with 3 births, you could say, for example, the outcome will be 2 boys and 1 girl. This is an example of a simple event because you can't break down 2 boys and 1 girl any further. This leads us to the concept of sample space. For any given procedure, the sample space is just all the possible outcomes that could occur from that procedure that are simple events. In other words, the sample space is the list of all the possible outcomes that cannot be broken down any further. Looking back at our single birth, the sample space here would be 1 boy and 1 girl, because for one birth, you could have either 1 boy or 1 girl. Those are the only possible outcomes you get from a single birth, and therefore this is our sample space. It contains 2 outcomes, both of which are simple events. In the case of 3 births, we've got a few more possibilities. You could have 3 boys, or 2 boys and then a girl and then 2 boys, or, well, you get the picture. You can see all 8 possibilities listed here in the table, and this is our sample space for 3 births. There's some specific notation that we use in statistics when dealing with probabilities. First of all, we're going to use the capital letter P to denote a probability. Then we're going to use letters of the alphabet, starting with A, B, C, to denote individual, distinct, specific events. Therefore, P of A denotes the probability of event A occurring. We would read this as the probability of A, or the probability that A occurs. Likewise, P of B denotes the probability of event B occurring. We would read this as the probability of B, or the probability that B occurs. P of A plus B denotes the probability that both event A and event B occur. We would read this as the probability of A plus B, or the probability of A and B. In addition to the special notation, probabilities conform to certain properties. They can be expressed in 3 ways. First, as a fraction. Second, as a decimal between 0 and 1. And third, as a percentage. Pure statisticians often frown on using percentages. I'm not sure why, but it's probably the same rationale for using the word mean instead of average. But I digress. Let's say we have as an example a 1 out of 4 chance. That's a probability of 1/4 when expressed as a fraction. We can express that also as a decimal. We just divide 1 by 4 and get 0.25, which we can express as a percent by moving that decimal point 2 places to the right to get 25%. So however you choose to do it, it's all the same value. Now, for any event A, the probability of A occurring is between 0 and 1 inclusive, which means it can be 0, 1, or any number in between. Keep in mind that if we're at the extremes of that range, the probability then has a special significance. If our probability is 0, that means the event is impossible. It cannot happen. There's absolutely no way for it to occur. On the flip side, if we have a probability of 1, that means we can't stop the event from occurring. It's unavoidable. It's an absolute certainty. So if we look at a number line between our extremes of 0 and 1, we see a scale of probability. On the one hand, we've got a probability of 0, meaning our event is impossible and certain not to happen. On the flip side, we have a probability of 1, which means our event is certain, unavoidable, and we can't do anything to stop it. Directly in between 0 and 1 is 0.5, or 50%. This means we have an even chance of either outcome. In between these markers, we have regions of likelihood and unlikelihood. So the closer we get to 0, the more unlikely the event becomes. The closer we get to 1, the more likely the event becomes. Typically, however, a good rule of thumb is to consider the probabilities of occurrence of less than 5%. This is going to indicate that the event is unlikely. Let's test what we just learned about probability. Which of the following numbers can be probabilities? First up, we have the number 1. Can this number be a probability? Yes, 1 can be a probability. And if you have a probability of 1, that means your event is certain. It's going to happen. What about 0.12? Can this number be a probability? Yes, this number can be a probability because any number between 0 and 1 inclusive can be a probability. What about negative 0.65? Well, this is not a probability. There is no way that's going to be a probability because it's negative. Negative numbers cannot be probabilities. What about 1.1? Well, no, this cannot be a probability either, and for similar reasons. Any number that's greater than 1 cannot be a probability. What about the square root of 3? Well, if you don't know what the square root of 3 is, go ahead and punch that out on your calculator. There's no problem with that and no shame in it either. So if you do that, you're going to get approximately 1.73. And since that number is greater than 1, the square root of 3 cannot be a probability. What about 2/5? Well, again, if you don't know that 2/5 is 40% or 0.4, you can punch that out on your calculator. 2 divided by 5 gets the 0.4, which is 40%. That's between 0 and 1. Therefore, 2/5 can be a probability. Let's look at another example involving a certain study which reported a 7 in 23 chance of encountering car trouble in a certain city. We're asked to express this degree of likelihood as a probability value rounded to 3 decimal places. Now, when you see two numbers separated by the word in and followed by the word chance, that means you're dividing the first number by the second number. So in this case, we'll take 7 divided by 23 and get 0.304. This then is the probability. Let's look at another example. You're certain to get a king when selecting 52 cards from a full and shuffled deck. Express this degree of likelihood as a probability value rounded to 3 decimal places. Well, what say you? Where would you start with this? You don't have numbers like in the previous example, but you do have a key phrase. That key phrase is, you are certain. What probability corresponds to an event that is certain to happen? I hope you just said 1 or 100% because that's what it is. You are certain means the event is going to happen. That means the probability is 100%, or expressed in decimal form, 1.000, since we're asked to round to 3 decimal places. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.